In this video, we'll be going over some basic introduction to some index law problems. So if you haven't done any index laws before, this is a perfect video for you. So I'll basically be starting it from scratch. So index laws are basically when you have something like, let's say you have x squared. This up here is its index, okay? And basically we're going to be looking at what happens, how we simplify things like this. Pretty much we have x cubed multiplied by x to the fifth, and how we sort that out, okay? So index laws deals a lot with algebra, so this is an algebra topic. If you know your index laws, there's some problems later in the video, but I'll basically just go over I'll go over 5 index laws basically for you. So this is the first index law. If you've never done this before, I'd like you to take down. So if you have if you're multiplying two things by the same base, so if you have a to the m multiplied by a to the n, that's the same as a to the m plus n. So if you're multiplying two things, these two have to be the same number. That's why I've put a here. If you had a to the m times by b to the n, that would not equal this, because they have to be the same number here. Okay, so this is only when you're multiplying two things of the same number or the same letter. So you notice how before I had x squared times by x to 3 or something. That's because they have the same thing here. They're both x, okay? It'd be the same thing if we had like b squared times by b cubed. Same thing here. It would not work if we had a squared times by b cubed. Not work because a and b are probably not the same thing. Okay, unless specified. So that's the first that's the first index law right here. If you want to copy that down, you can. I'm just gonna make that I'm gonna make the whole thing a bit smaller and move it to up here. So our second index law. If you have a to the m divided by a to the n, that's the same as a to the power of m minus n. Okay. So it's pretty much, it can also be written like as a to the m divided by a to the n. It's pretty much cancelling the number on top. So if you had x to the 5 and you had x squared, that's the same as saying having x times x times x times x times x. So there's 5 of them, and x times x. It's basically just cancelling what's on the bottom and the top. Okay, so you're left with x to the cubed, because x to the 5 minus 2 is x to the cube. Okay, so that's second index law explained. Alright, yeah, so that if you understand these two laws, you can pretty much solve most index law problems already. There's just one more one that's a key one. It's this one. So if you have a to the m to the exponent of n, that's the same as a to the m times by n, okay? So if you have x squared all to the 5, that is equal to x to the power of 2 times 5. Okay, so that's x to the 10. Alright, so that's the third law pretty much. Fourth law. Fourth law. So if we have a times b, and a and b are not the same number, to the power of m, that's the same as a to the m times by b to the m. So this gets distributed to all the numbers in here. This is only if it's multiplying or dividing, okay? If you have any other operation in there, this will not be the case. Like if this here was a plus sign, this would not work, okay? At all, alright? So, that's the fourth law. The fifth law, let's write that out. If you have, of course, a over b to the power of m, that's the same as a to the m divided by b to the m. Okay, so it's pretty much very similar stuff. All right. Another important thing: if you have any number to the power of 0 is equal to 1, that's pretty much a definition. Okay, that's so important, because it appears everywhere in math. It appears in calculus, algebra, you name it, this thing will pop up. Logs, everything. Okay? So if you just follow these index laws here, you can basically solve most index problems pretty much. All right. So if you want to copy these down, and if you don't want to keep scrolling back in the video, I copy these down on a bit of paper, and just refer to them as we do these problems. Okay. So let's move on. So in this video there'll be 10 problems. It'll be a range of difficulty, but this video is mostly for beginners. So let's just get to question 1. All right. So this is question 1. X to the power of 5 multiplied by x to the power of 4. So if you want to have a go at this problem, feel free to pause the video. If not, I'll explain it shortly. Alright, so first off, what's our first index law? If you have a to the m times by a to the n, you basically just add them, okay? So we can see these are the same numbers here. So we have x to the 5 multiplied by x to the 4. So that's the same as x to the 5 plus 4. So that's x to the 9, okay? If you were in a test and it asked if this was like out of 2 marks and you just wrote that, I'd probably only give you 1 mark. If you wrote this step here, I'd probably give you 2, okay? But if it was a 1 mark question and you just put this here, you get the mark, okay? So you just got to read your marking grid of exams. So if you had something like this, it could be just simple, just x to the power of 9. But if it was like a 2 marks, you might want to write like this and then that. But it depends on the question and the marking, of course. Alright, so that's the full working for question 1. Hopefully you all got that, or you understand how I got that. So it's just the first law here. Alright, let's go on to the second question. Alright, so question 2, 3 times a squared times b multiplied by 4a times b to the 3. Okay. Feel free to pause this if you want. Pause the video if you want to have a go at this problem. Alright, so this one's a bit trickier than the last one. We've really jumped the gun. So we've got 3a squared and b times by 4ab cubed. Okay. Obviously, we can multiply our numbers because we know how to do that. But our index laws will only apply to things with like bases. So to apply our index laws with our a's, we can only do it with this other a over here. And with our b's, we can only do it with this other b over here. Okay, so what I'm going to do, I'm just going to get rid of all these circles now. So I'm going to do 3 times 4. So this is my first line of working. 3 times 4. A squared plus 1, because that's our first index law. So recall a to the m times by a to the n is a to the m plus 1. Okay, so all I'm doing is I'm ignoring the b, I'm just focusing on the a's first. So that's what I'm doing here, okay? Because if you have just a, that's actually a to the power of 1, okay? Alright, cool. So I'm just doing the a's, okay? And now I'm just focusing, next thing I'm doing is just focusing on my b's, okay? I'm ignoring else and just focus on my b. So b to the 1 plus 3 because they're multiplying. Simplifying the front, you have 12. Simplifying the a's, you have 3. Simplifying the b's, you have 4. Okay? So this is the answer. Okay? So when you have a problem like this, just look at the like terms and stuff. Because if it's multiplying, just look at the a's with the other a's. Don't mix index laws with variables that don't have the same base. So if you went a with the b, that's a big fat X, okay? Only do it with like bases. That's the whole point of these index laws. They have to be the same base, okay? Alright, cool. Same base, you can add the indices if you're multiplying them. If you're dividing things with the same base, you minus the indices, okay? Alright, cool. That's the answer to question 2. If you got that wrong and you're not sure why, leave something in the comments and I'll try and answer it or make a follow-up video, okay? Alright, question 3. M to the power of 7 divided by m to the power of 5. So if you want to have a go at this question, feel free to pause the video. Alright, so m to the 7 divided by m to the 5. So m to the 7 divided by m to the 5. Alright, that's our second index law. So recall a to the m divided by a to the n is the same as a to the m minus n. Okay? So just applying this law, we're going to know it's going to be m7 minus 5. Because if you rewrote this in another way, that's so m to the 7 divided by m to the 5 is the same as m to the 7 over m to the 5, which is the same as m times m times m times m times m. How many is that? Times m divided by m times m times m times m times m. Okay? It's the same as just cancelling the number on the bottom. Okay? And you're left with only 2 m's on the top because the rest have cancelled out. Alright, using our index laws, that works out 2, and that works out 2. Okay? So you can either do it this way, or you can think of it like this way. However, if you get really big numbers here, I recommend doing it this way, because you don't want to keep writing out all these m's. I only wrote out all those m's to help people with the understanding of what's actually going on. Okay? Hopefully that makes sense. This is the answer, by the way. Alright, let's move on to the next question. Alright? So question 4. 4x squared times by y to the 5 divided by 8xy squared. Alright, if you want to have a go at this question, feel free to pause the video and have a go. Alright, so first off, I'm going to rewrite how this looks. So I'm going to have 4x squared times by y to the 5 divided by 8xy squared. Okay? Alright, straight up from the back, look at my numbers by themselves. 4 divided by 8, that's a half. Okay? So we'll keep that information in to the side somewhere. Okay? Alright, you have x squared over x. That's what you have right here. Okay? So that's our second index law. So that's going to be x to the power of 2 minus 1, which is just x. Okay? Third of all, we're going to have our y's here. So we have y to the 5 divided by y squared. That's the same as y to the 5 minus 2, which is equal y to the 3. Okay? Alright, cool. We've sorted everything out individually. So, actually, I'll just move all this because it's in the way now. Move that. Oh, what is this? I've taken from the page before. I'm just going to rub this out because we don't need it anymore. Alright, so simplifying this, we're going to have 1 here, we have a fraction here, we're going to have a half here. We're going to have our x on the top, which is x here, and our y cubed on the top. So simplifying that, that is x times y cubed all over 2. So that is our answer. If you're a bit confused, leave something in the comments. All you got to do is just look at each thing individually. So straight from the back, I looked at the numbers first, and then I looked at the x's, and then I looked at the y's, and applied the index laws. So I did arithmetic here, I did my index laws here and here. Okay? Alright, let's go on to question 5. Alright, a to the power of 3, all to the power of 4, all to the power of 4. So if you have a go at this question, feel free to pause the video and have a go. Alright, so this is our third index law. So recall, if you have a to the m all to the power of n, that's the same as a to the power of m times by n. So this is actually very similar to that, so we can just replace our letters here. So we have a to the power of 3 all to the power of 4. That's the same as a to the power of 3 times by 4. 3 times 4 is 12, so that's a to the 12. So this turns into a to the 12. And boom, that's the answer. Let's move on to the next one. Question 6. 2 times y to the 5 all to the power of 3. So if you want to have a go at this question, feel free to pause the video and have a go. Alright, straight off the back, it's our our third index law. So it's this law again. Alright? Alright, so except it's also a combination of law number 4. So law number 4 is a times b all to the power of m is equal to a to the m times by b to the m. Okay? If you have 2x, that is basically 2 times x. That's what that means. Okay? So in here, I'm just going to rewrite this whole thing here. 2 times y to the 5 all to the power of 3. So according to our fourth law, we have to distribute these 3 because they're getting multiplied here, right? Alright, so doing this, we're going to have 2 to the 3 multiplied by y to the 5 all to the 3. We're going to apply this law over here to the y. So we're going to have 2 to the 3 times by y to the 5 times 3. This 2 to the 3 is the same as 2 times 2 times 2. 2 times 2 is 4, times by 2 is 8. So therefore that is 8. 5 times 3 is 15, so it's y to the 15. And that is our answer, okay? Alright, let's move on to question number 7. Alright, question 7 is probably the hardest question in the video. It combines a lot of ideas together. Actually, no, it's probably not the hardest in the video. I think the next one might be the hardest in the video. So let's have a go at this question, okay? So if you want to have a go, feel free to pause the video and have a go. Alright, so straight off the back, we are going to use, actually this isn't quite hard as I thought it was. All it is pretty much is just law hashtag 3 and law hashtag 4, which is a to the m all to the power of n, which equals a to m times by whoopsie daisy, which is m times n. And we have law 4, which is a times b to the power of m is the same as a to the m times by b to the m. Okay, so let's just rewrite this here. So we have 3x squared all over 5y squared to the z, and we have this 3. So this is being multiplied here, and this is being multiplied here, and this is being multiplied here. So we need to distribute the 3 to here, to here, to here, to here, and to here. Okay, that is a lot of here's, alright? So I'm going to rub out my red stuff, and I'm going to start doing it, alright? So I'm just going to simplify this whole thing up here into this here. So we're going to have 3 to the power of 3 times by x squared all to the power of 3. Divide by 5 to the power of 3. Divide by y squared all to the power of 3. Divide by z to the power of 3. Okay? So you see what I've done? I've distributed the 3 to the here, 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 here. And that's how I got that. Alright? Hopefully that made sense. Hopefully I didn't lose any of you, alright? So all I did was law 4. All I did was this law, okay? So let's move on. Let's actually make this a bit smaller because I've made it a bit big. Alright, so let's sort out our numbers. Let's sort our numbers first. So 3 to the power of 3 is the same as 3 times 3 times 3. This is going to be equal to 9. 9 times 3 is 27. So we're going to have 27 at the top of our fraction. 5 to the 3 is equal to 5 times 5 times 5. That's 25. Oh, 25, not 12. That's 25. 25 times 5. That's 25, 25, 25, 25, 25. That whole thing there is 100. So our answer is 125. 125. X squared all to the power of 3. So this here, that's just going to be this law over here. So that's going to simplify to x to the power of 6. This thing down here, y squared all to the power of 3 is just law 3. So that's going to be same as x squared, x to the 6 is just going to be y to the 6, okay? And our z cubed is going to stay the same, okay? So there's our answer for question number 7. Hopefully you didn't get lost during that. If you did, I'll just comment down below. Alright, question 8 now. This is the hardest one. Alright, feel free to pause the video and have a go at this one. Alright, so straight off the back, we have a monster here. So I'm just going to rewrite. So 3 to the power of x, 3 times x, y squared, all to 3, multiplied by 4, x to the 4, times by y squared, all over 8x squared to the y. Alright, so straight off the back, I'm not going to write out the laws anymore because I'm pretty sure you guys should know them or you've written them down somewhere because I'm sick of writing them out. Alright, we're going to distribute our 3 here and here. So we're just going to deal with the top of the fraction first. We're going to have 3 to the x to the 3 times by y to the 6, because not y to the 6, yep, that's all good. Those are 4 y squared all over 8x squared to the y. Alright, we're going to deal with our numbers first, and then our x's, and then our y's, okay? So we're going to have 3 times by 4, x to the 3 plus 4, y to the 6 plus 2, all over 8x squared over y. Alright? So all I did was apply my indices laws to my my x's, my y's. That's all I did to get to here, okay? Alright, cool. If you didn't understand that, leave something in the comments. 3 times 4 is 12, so I can just rub that and replace it with the 12. 3 plus 4, that's 7. So I'll replace that with 7. And 6 plus 2 is 8. So we're going to turn that into an 8. And we're going to combine all this and make this a bit tighter together. Or not, it's not behaving, so I'm just going to write it together. Y to the 8 all over 12. Alright, so now what we're going to do. Let's deal with our numbers first here. So 12 divided by 8. 12 is the same as, 12 is equal to, it's the same as 3 times 4. And 8 is also is equal to 2 times 4. So if we just replace those with these products here, we'll have 3 times 4 all over 2 times 4. And of course, the 4's cancel, so we're left with 3 over 2. Alright? So this is our new fraction here, 3 and 2. And I'm going to extend that fraction. Here we have our second index law. So we're going to have x to the 7 minus 2. And here we also have our second index law. So we're going to have y to the 8 minus 1. So we're going to be left with 3 x to the 5 and y to the 7 all over 2. Alright, cool. That is the answer to question 8. If you had any questions, comment, of course, and I'll try to respond to it. Alright, question 9. So if you want to have a go, feel free to pause the video. Alright, straight off the back, I'm just going to start writing this out a bit differently. So I have r times by r, 3 times r to the 5 times by s squared divided by r to the 3s. Alright, straight off the back, we have a number here. So we're just going to leave that as a 3 at the top. We're going to deal with our r's first. So that's our second index law. And we're going to do the s's, and that's also our second index law. So this is going to simplify to 3r to the 5 minus 3 multiplied by s squared minus 1. Okay? So that's going to simplify to 3r squared multiplied by s. Alright? And that is the answer to question 9. And of course, our last question here. So if you want to do this last question, feel free to pause the video and have a go. Alright, straight off the back, I'm going to start writing this out a bit differently. I'm going to write this as a whole fraction. So I'm going to have 6 times by p to the 4 times by q to the squared divided by 3 over q squared over p squared. Okay? Now they've done something a bit tricky here. Well, they haven't done anything tricky, but they've put in a sneaky thing. They've used p's and q's. The p's and q's look alike, except they're not in the same position. As you can see, the q's here, while the q on the top is over here. And the p is here, and the p is down here. So be careful not to mix up your p's and q's, okay? I know it sounds silly, but a lot of people do it. So first off, we'll deal with our numbers. 6 divided by 3, that's going to be 2. So top of our fraction. Our q's, we're going to deal with. So our q's, not our q's, our p's. Our p's are here. So we're going to have p to the 4 minus 2. And then we're going to deal with our q's. So we're going to have q2 minus 2. And nothing on the bottom of the fraction. Okay? So we're left with 2p squared multiplied by q to the 0, because 2 minus 2 is 0. And recall, any number to the power of 0 is equal to 1. So this whole thing is just equal to, this thing here is equal to 1. So we can just rub that out, because, yeah. And boom, that is our answer. Alright, I hope you enjoyed this video. If you want any more videos on index laws, let me know. I hope this video helped you. See ya.